Welcome to Section 3, Lesson 10. Across the previous 9 lessons, we built every solving technique for linear equations and inequalities: one-step, two-step, both sides, literal equation rearrangements, single variable inequalities with the flip sign rule, compound inequalities with and or connectives, absolute value equations with case splits, absolute value inequalities with expansion rules, and full word problems with the 4-step framework. Today is the marathon lesson where we apply all 9 skills back to back on a mixed sequence of challenges. Mixed practice is the most efficient learning move in all of mathematics because it forces you to first identify the type of problem and only then apply the relevant rules, which is exactly what tests and real-world applications demand. Single skill drills leave you fast at one task, mixed marathons leave you fluent at the whole toolkit. First idea on the board: mixed practice exposes the soft spots in your skill set in a way that single topic drills never can. When every problem in a homework set is a 2-step equation, you settle into a rhythm and your reflexes carry you through even when you do not really understand the rules deeply. When the next problem might be an absolute value inequality or a literal equation rearrangement or a word problem, you have to first decide which toolkit applies and only then start working. The decision step is exactly where weak students stumble and strong students breeze through. Today, we exercise that decision step deliberately by mixing problem types in a deliberate sequence. The full Section 3 toolkit has 9 solving skills, and you should be able to name them all from memory before starting the marathon. The skills are 1-step inverse, 2-step reverse, PIMDES inverse, gather, then 2-step for both sides equations, literal equation rearrangement using letter constants, single inequality with flip sign, compound inequality with and or connective, absolute value equation with case split, absolute value inequality with expansion rule, and 4-step framework for word problems. Every problem in the marathon today exercises some subset of these 9 skills, and the first move on every problem is identifying which subset is in play. Third idea: speed and accuracy on mixed problems come only from reps, never from reading the rules. The rules are short enough that a couple of hours of careful reading covers all 9 skills. The fluency that lets you solve a mixed problem in under a minute rather than 3 minutes comes from 60 or 80 practice problems spread across the next 2 weeks of homework. The marathon today is a starter set. Commit to working a similar mixed set on your own time over the rest of the chapter, and the Section 3 material will lock in as automatic background knowledge that the rest of the algebra course can build on without conscious effort. The full Section 3 toolkit has 9 solving skills, and a marathon-style mixed practice session is the most efficient way to lock them in as fluent reflexes. The first move on every mixed problem is to identify which skills the problem requires. Only after that identification do you apply the relevant rules. Today, we make the identification step explicit so you can train it deliberately rather than absorb it by accident. Skills 1 through 3 are the equation core. 1-step inverse handles equations like x plus 7 equals 12 or 3x equals 18 with a single addition or multiplication on the variable. 2-step uses reverse PEMDAS to undo 2 stacked operations. Both sides equations add a preliminary gather step before the standard 2-step procedure. Together, these 3 skills cover most pure equation problems and form the algebra mechanics layer of Section 3. Skill 4 is literal equation rearrangement, where the constants are letters rather than numbers, and the result is a reusable formula rather than a single number. Skill 5 is single linear inequality, where the equal sign is replaced by an inequality symbol, and the flip sign rule triggers when multiplying or dividing by a negative number. Skill 6 is compound inequality with and or connectives, where 2 simple inequalities combine into a chain or a union of disjoint intervals. Skills 7 and 8 are the absolute value family, Absolute value equations isolate the bar, chunk, and case, split into two simple equations. Absolute value inequalities also isolate the bar chunk first, then expand into a chain or compound using the less than and greater than or rules. Both skills layer the absolute value structure on top of the equation or inequality machinery from earlier lessons. Skill 9 is the word problem 4 step framework. Define the variable, translate the English to algebra, solve the equation, verify in the original English context. The framework wraps any of the previous 8 skills inside a translation phase at the front and a verification phase at the back. When you face a mixed problem, the workflow is read the problem, identify which skill or skills apply, order them if multiple apply, then apply each in turn. Today's two worked examples each combine 3 or 4 skills with the identification step made explicit so you can practice the decision-making layer rather than just the mechanics. Here is the first marathon problem. Solve the equation 3 times the quantity 2x minus 1 equals 2 times the quantity x plus 4 plus 5. The problem combines distribution, both sides gather step, and the standard two-step inverse procedure. 3 skills layered into one equation, exactly the kind of mixed challenge the marathon is designed to train. Step 1. Identify the skills required. The equation has parentheses on both sides, which means distribution comes first. After distribution, it has the variable on both sides, which means the gather step. After gathering, it will be in two-step form, which means the reverse PIMDIS inverse procedure. 3 section, 3 skills in play, in a clear order distribute, gather, two-step. Step 2. Distribute on both sides. The left side 3 times the quantity 2x minus 1 becomes 6x minus 3. The right side 2 times the quantity x plus 4 becomes 2x plus 8. Then plus 5 gives 2x plus 13. The equation is now 6x minus 3 equals 2x plus 13 with no parentheses and the variable on both sides. Step 3. Gather the variable terms onto the larger coefficient side. The left has 6x and the right has 2x, so subtract 2x from both sides to gather to the left. The left becomes 6x minus 3 minus 2x, which combines to 4x minus 3. The right becomes 2x plus 13 minus 2x, which simplifies to 13. The equation is now 4x minus 3 equals 13, the standard two-step form. Step 4. Apply reverse PMDS two-step. Add 3 to both sides to get 4x equals 16. Divide both sides by 4 to get x equals 4. Verify by substitution 3 times the quantity 2 times 4 minus 1 equals 3 times 7 equals 21. 2 times the quantity 4 plus 5 equals 2 times 8 plus 5 equals 16 plus 5 equals 21. Both sides equal 21. Solution verified. So the solution is x equals 4. The big lesson from this example is the layered skill workflow on a problem that touches 3 sections, 3 skills in sequence. Distribute first to remove parentheses, gather variable terms onto one side, then apply the standard two-step inverse procedure. Each layer uses a skill from a previous lesson, and stacking them in the right order is the entire game in solving harder linear equations. The verification at the end uses the evaluation skill from section 2 and confirms the layered work is correct. Here is the second marathon problem. Solve the absolute value inequality, absolute value of 2x plus 1 greater than 7. The problem combines absolute value isolation, the greater than gives or expansion rule, and 2 parallel one-step solves. 3 skills layered into one inequality, with the absolute value structure as the dominant feature. Step 1. Identify the skills required. The inequality has an absolute value chunk on the left and a positive number on the right with the greater than symbol. The absolute value is already isolated, so the expansion rule can run directly. The greater than triggers the or expansion. After expansion, 2 parallel one-step linear inequality solves complete the work. Step 2. Apply the greater than or expansion rule. Absolute value of 2x plus 1 greater than 7 expands into the or compound 2x plus 1 less than negative 7 or 2x plus 1 greater than positive 7. Two cases joined by or ready for parallel solving with the lesson 5 inequality procedure. Step 3. Solve the first case 2x plus 1 less than negative 7. Subtract 1 from both sides to get 2x less than negative 8. Divide both sides by 2 to get x less than negative 4. The first solution range is x less than negative 4. Step 4. Solve the second case 2x plus 1 greater than 7. Subtract 1 from both sides to get 2x greater than 6. Divide both sides by 2 to get x greater than 3. The second solution range is x greater than 3. Both solves used positive divisors, so no flip rule was triggered. Step 5. Combine the two case ranges using the OR union. The first range covers all values strictly less than negative 4. The second range covers all values strictly greater than 3. The two ranges do not overlap, so the combined solution is two disjoint intervals x less than negative 4 or x greater than 3. Verify with test values. X equals negative 10 satisfies the first range, equals 5 satisfies the second range. X equals 0 falls in the gap. An absolute value of 2 times 0 plus 1 equals 1, which is not greater than 7, correctly excluded. So the solution is x less than negative 4 or x greater than 3. The big lesson from this example is the layered absolute value inequality workflow. Confirm the absolute value is isolated. Apply the appropriate expansion rule for the inequality direction. Solve each resulting case in parallel using the lesson 5 inequality procedure and combine via the connective the expansion rule produced. The greater than gives or pattern produced two disjoint intervals as expected. Both case solves were one step and clean. The verification at multiple test points confirmed the boundary endpoints behave correctly. Mixed skill problems like this one are the natural unit of work in standardized tests and applied math, and fluency comes from reps over the next 2 weeks of practice. 3 patterns that catch every algebra student during their first weeks of marathon-style mixed practice. Each one is fixable by a small explicit habit applied between problems and at the end of every problem. First pattern: applying the wrong skill first because you misread the problem type. A student sees an absolute value inequality and immediately starts case splitting before checking that the absolute value is isolated, or sees a both sides equation and starts gathering before distributing the parentheses on either side. The cure is the explicit identification step at the top of the workflow. Read the problem, name the skills required, decide their order, then apply them. The identification step costs 10 seconds and prevents an entire wasted attempt at the wrong skill set. Second pattern: carrying the previous problem's mental model over to the next problem. The previous problem required the flip sign rule because of a negative coefficient, so on the next problem you flip the inequality direction, even though the new problem has no negative multiplier. This carry-over error is unique to mixed practice and is exactly why mixed practice is so valuable for diagnosing weak spots. The cure is to consciously reset your mental model between problems. Take a 1-second pause, reread the new problem from scratch, name its skills before starting work. Third pattern: skipping the verification step because you are in marathon mode and trying to move fast. Mixed problems hide errors more effectively than single topic problems because there is no rhythm to fall back on, so the verification step is even more valuable in mixed practice than in regular homework. Always plug the answer back into the original problem and confirm both sides match for equations or that test values inside the range satisfy the inequality. The verification step takes 5 to 10 seconds and catches the vast majority of marathon errors before they become wrong final answers. Mixed skill marathon practice is the dominant style of math evaluation across nearly every standardized test, contest, professional interview, and applied setting. Specialized single skill practice is useful for building each individual skill, but mixed practice is what builds the fluent decision making that real-world math problems demand. 4 broad domains below. On the S8 ACT, GRE GMAT, and most state algebra exams, the math sections deliberately mix solving types within each section so that students must first identify the type of problem and then apply the relevant skill. Test writers know that mixed practice is the gold standard of fluency assessment, so they test in exactly that style. Students who have done 60 or 80 mixed practice problems before the test consistently outscore students who only did single topic drills, even when both groups have studied the same total number of hours. In oral math exams, whiteboard interviews for tech and finance jobs, and oral defense exams in graduate school, the examiner jumps between topics rapidly to test whether the candidate has fluent recall and decision making rather than just textbook knowledge. The candidate has to identify the right skill from a quick spoken description and apply it cleanly on a whiteboard with no time to think. Mixed skill marathon practice is the only training mode that builds this kind of on-demand fluency, and the skills you are building this week scale directly into that work. On the AMC AM math counts and other contest math problems, every problem combines 3 to 5 skills in a single problem statement, and the contestant has roughly 2 to 4 minutes per problem. Recognizing the skill set required and applying them efficiently is the entire game in contest math, and contest students train mixed practice intensively for exactly this reason. The decision-making layer you exercise in today's marathon is the same layer that drives every contest performance. In programming and algorithms work, especially in coding interviews at major tech companies, candidates are presented with problems that require recognizing a pattern from a small library of standard algorithmic templates and adapting that template to the specific problem. The skill is essentially the same as algebra mixed skill marathon pattern recognition, followed by mechanical application. Software engineers who have practiced this kind of mixed pattern matching work move noticeably faster on interviews and on real engineering tasks than those who have not. 3 things to take with you from this marathon lesson today. Mixed practice is the most efficient learning move in all of mathematics, and the Section 3 toolkit is now complete enough that you can practice every skill in mixed combinations from this lesson forward across all the rest of the course. First, mixed practice is the gold standard of fluency training. Single skill drills are necessary for building each individual skill, but they cannot substitute for mixed practice when you need to recognize problem types and switch toolkits on the fly. Every standardized test, every applied math problem in science and engineering, and every real-world calculation in finance or contracts is a mixed problem. Train for the mixed condition by doing mixed practice as soon as the individual skills are at least passable. Second, the first step on every mixed problem is to identify which of the 9 Section 3 skills apply in what order. 1 step, 2 step, gather both sides, literal rearrangement, single inequality with flip rule, compound inequality, absolute value equation, absolute value inequality, and word problem 4 step framework. Read the problem, name the skills, decide their order, then apply them. The identification step takes 10 seconds and prevents the wrong skill, first error that wastes minutes of misdirected work on every problem it occurs in. Third, always verify your final answer by substituting it back into the original problem context. For equations, substitute and check that both sides equal the same number. For inequalities, test values both inside and outside the proposed solution range and confirm they behave correctly. For word problems, reread the original English and confirm the proposed answer makes sense in the described situation. The verification step costs 5 to 30 seconds depending on problem type and catches the vast majority of marathon errors before they become wrong submitted answers. Coming up next, Section 4 opens with the coordinate plane, where the linear equations you solved across Section 3 are visualized as straight lines on a grid, and the algebra of equation solving connects to the geometry of intersecting lines. Section 4 is therefore the natural visual completion of the Section 3 solving work, and the skills you have built across this section transfer directly into the geometric thinking of the next section without modification.